So good afternoon to every audience. My name is Fran and I will be your MC for today. I would like to welcome everyone to the last webinar sessions of today at ASEAN's Energy and Utility Digital Week. So we shall be discussed under the topic of ASEAN Data Center for Energy Management. So this webinar is organized by the King Mongkut Institute of Technology Lat Krabang and Data Center University.org together with the Informa Markets in Thailand. And powered by the ASEAN Sustainable Energy Week 2021 or ASEW, the ASEAN largest international exhibition and conference on renewable energy, energy efficiency, environmental and electric vehicles technologies, which will be held on 14 to 16 October this year in Bangkok, Thailand. So in these sessions, we will be discussing about the impact and highlights the latest technologies, the energy sources, the energy management and monitoring consumptions and optimizations of data center facilities. So we bring together our speakers from the world's leading company who are specialized in data center management. Before we go to that, I would like to take this opportunity to thank you to our Diamond sponsor. So Delta is our sponsor for this session. So thank you very much. And also, I would like to have a quick notice to the audience who will be in our conference theater. So on your bottom right corner, that is the webinar assistant icon. So during the webinar, the live discussions between audience is available. So if you like to put the message there, you can go to the chat tab. And if you would like to ask the question to our speaker, so you can go to the question tab and don't forget to mention our speaker name before you write down the questions. And if you find any problems during the webinars, you need help, you can leave a message at the help tab and our staff will get back to you. So without any further delay, I would like to introduce to our moderator for today. So he is Associate Professor Dr. Montri Vibunrat. So he's a Big C Thailand Country Chair and Associate Professor at KMITL Business School. And he also has a long experience about the data center system, reliability, data center, and the energy efficiency, cloud computing, IoT, smart cities, smart grid, waste to energy, renewable energy, and business continuity management. He is also the founder of the Data Center University.org. So he's very long experience on this. I believe that he will moderate these sessions and bring the good content to the session as well. So good afternoon, Professor Montri.
Yes,
I would like to pass this floor to you.
Yes, okay, thank you.
Okay,
Goodbye.
thank you.
Okay, I will start our sessions because as you know about our session, we're talking about Asian Data Center for Energy Management, that we have the three expertise panelists today. First will be Mr. Wong Kevin and Mr. Papong and Mr. Sakda. Okay. Let's start with Mr. Wong Kevin. He have more experience for the data center, more than 35 years. He have been a consultant for many data center. Okay, welcome, Mr. Wong Kevin.
Mr. Wong, I think you are on mute.
Good afternoon, everyone. And It's good to be back in Thailand, although it's virtual. And I hope that we can soon be able to communicate and come back to Thailand to work on some of my data center projects there. So in terms of energy management, it is energy management has been a constant requirement in the data center industry for the past 5 to 6 years. But today, I think it is getting beyond just managing it. It's about understanding the efficiency and the effectiveness of what you're doing in your own data center, and understanding how to, in order to optimize your energy usage, you first have to understand how your customers use that. And to do that, you require you to not only just capture the information, which, by the way, most data centers today are designed to capture the energy information. The only problem is that we are not all the data centers are able to understand how to take that data on energy and then extrapolate that into some form of a management dashboard so that we know how to use that information to make our data center a lot more efficient and be more efficient at how those energy are being deployed. For example, let me give a simple example. So a simple thing like when a new customer come on board and we want to quickly know what amount of UPS power is available to be deployed when the sales team come and ask you, oh, I've got a new customer and I need 100 kilowatt. And in those data center that doesn't have the correct type of operation support system to give you that ability to ask that question and then report back on what's your availability and whereabouts, which floor of your data center actually have that 100 kilowatt of capacity available and in how many racks. So it's a very simple question sometimes, and we don't realize that to get that answer to a very simple question requires a lot of systems to be put in place so that you know exactly what energy is available, where is it available, and how can we provision it. So these are the three fundamental things we have to do. And today, this sounds simple, but to do it, you need to design it into the way you operate and actually when you deliver that data center. It's no longer about delivering a building. It's about delivering an entire what I call a platform for you to be able to meet your customers' requests on a real-time basis. So that, in essence, is really what we are talking about in the most simplistic way. So I'm going to use that as an introduction, and I'll hand it off back to my friend, Dr. Montre.
Okay, thank you for Kevin for introductions about this one. The second one will be Mr. Patpong Petkana. He is more experienced. He working on Schneider, and as I know right now, he is a PhD student working on the data center as well. And welcome, Mr. Patpong.
Hello, I'm Patpong speaking right now. Actually, I'm do for the data center consulting and design at Schneider Electric. For the way right now is like the data center have many variable that we have to design and make it to more efficiency. It's not just only for energy efficiency, but by the way, they have to take care about everything inside the data center, including the outside. Also, is including the climate change in the world right now. We have to check on that one. By the way, we also have to design the data center and operate data center to match with the changing in the world right now of the IT equipment. One thing that is very important right now to make is simple, like Kevin said, is we should define and we should implement more the software into the data center to control and design for the infrastructure itself that can make more the energy efficiency in the future. Yeah. Okay, that is.
Good Patpong, I think you have some slide to present. You can share that one.
Okay. Yep. I also have the slide.
Okay.
Wait a minute. I will share this one. Okay. And anyone see my slide, right? Okay. From this one, actually from the data center itself, we will have a next wave for the sustainability and digital transformation. It's not just only the efficiency in the data center, but we should make the data center is sustainable and digital transformation from this one. By the way, in terms of the General Electric, we are doing the empowering of very simple one that we would like to do is like the most of the energy resources. And then we can do is like the digital partner for sustainable. Okay. In terms of the industrial chains, we have over than 200 years for the industrial chain. Right now is starting from the industrial ones until right now we go for industrial 4. In terms of the information and electricity, we also going up starting from electricity 1 until electricity 4. So right now from the electricity 4, we have the IoT that we can communicate every data in the world to be the IoT. We can do the AI, we can do the measure machines. And also right now, we know that is the digital is the routing efficiency and sustainability. So, but this routing is a good way. So we should understand on this one how we can use the digital to be the data center sustainability. In the world right now, if we're talking about the sustainability, right? The sustainability in the data center is very complicated, but it's a long-term challenge that we have to prepare. Any level, like a C-level, or the action, or the investor need to take care on that one. For this kind of thing is not good only for the planet, but that is good for what we have to learn from the building industrial. One in the industrial to embed sustainability, leaders see that sustainability is make a company more efficiency and stronger. Like for this one, in this slide from the static from 451 research saying that is 97% for the customer expect to see the contractual commitment for the sustainability. Right now in ASEAN, we also have the big company come to our regions. It's like the Microsoft, Facebook, Google, Amazon, or the Apple. Most of leaders seeing that is they will commit after 2020. They will looking for actionable sustainability plans. For this one, you can see is the growth of data until 2025, more than 500% will be increased. In terms of the electricity also at the same time, it will be increased around 50%. It's not just only the big data, it will be related to edge computing. You will see a lot of edge computing that also increase the power up to 75%. It means that the data center will change a lot. In the future, over than 24% will be self-configuration. How to self-configuration is mean that the software can be self-configuration the data center in the future. So that's why I said that is edge computing will be much more power. It's not just take only the big data. In the future, it's not too long. The energy in the edge computing should be much more than big data in the data center. Around 15 years ago, we just focused on the energy usage. The word that in data center business is related to the PUE. And then from the PUE is also improvements starting from the 2016 until 2020. And today, right now, is around 1.95 generally of the big data center. By the way, for some application is like the big giant data center, they also improve the PUE that are different from the general big data center. Is maybe less than is 1.1 or 1.11. This is based the PUE right now. By the way, this one is not a direct challenge right now. In the future, the PUE or the power usage is not just only to make the data center sustainable. By the way, we have to focus on the 4 vector right now that for the new wave digital transformation. As term of this one, our vision is looking at the sustainability, looking at the efficiency, looking at the adaptability, and also resiliency. Those are 4 pillars. Vector, this one should be take care to data center sustainability. Right now, where we are. From that, where we are is like the big giant data center or enterprise data center. We will see right now, most of the data center already improve the efficiency. But one thing that they did not do it yet is like the sustainable, adaptive. For the resiliency, they do already in terms of the infrastructure that make more resiliency data center. Right now is a lot that where we should be improved. Right now, we should improve on the sustainability and also adaptability. For each point of the vector is like the sustainability. Sustainability, we should take care, we should have the consulting, or sometimes we should have the strategy to take care on the carbon strategy, on the renewable energy. In terms of the resources management, also important for the sustainable. The next thing you can see that we just focus right now, and we focus a lot on this one. It's not just only the design. We should take care on the high density IT space. If we can make the high density IT space, we can make more energy also. We should understand the equipment that used in data center, right? Like is a high efficiency of the design. We should understand the capital and investment. We should understand is like the digital service that should be improved for data center operation. For the number 3 vector is like adaptive. Because of the IT change very fast, the design, like flexible of the design deployment at the service also, we should design to adaptive for the future IT improvement, like the quantum system, like HPC system. We should design the system of the data center to be support on that fund. One thing important on the data center is like the software design. Right now we can do is like the workload and application for portability. And in terms of the active energy management, we also can manage data center to be more efficient. And the last one is like the resiliency. Also very important on that one, that we have to take care of the power and cooling resiliency. And those of this one also weak point for the data center efficiency. By the way, resiliency is very important on data center. Remote management also need to be taken care. And in terms of the cloud computing, the cybersecurity also have to be improved. Between on this one, when we implement those of the management, the data center analysis, the data analysis, including the service analysis, we can do pass to the software management. Those of them, this one we can make for next September data center. And then for this one, our value in terms of the generalistic, we see the 3 areas. First area is related to the connected device offer. The second area is integrate everything together. After that, we use the software and service to be control the data center and make more availability and efficiency. For the connected device right now, make more efficiency and sustainability, we use the digital tool for the data center design. And this one will be portfolio to be the online configurator tool to be designed from the IT room, power system, design for the cooling system, in also including the edge data center. For this design can make the data center starting from the small data center, maybe starting from 10 kilowatt until 100 megawatt design. This one can be huge in the work of the data center. So from this one, in terms of the data center design, we can add more the new technology in terms of the data center is like the edge station. In terms of the micro data center, we have the liquid cooling that can add for data center application for support to be the HPC system. Use the raw data center in terms of in the future to reduce more energy related to the cooling system. We can use the OPC system for the new data center and support the quantum computing. We can add the resiliency and adaptive by using the modular all-in-one data center. We can implement very fast one. And also in the Asia, we also can implement like indirect air economizer, can reduce much more the efficiency, the power usage from the cooling system. Right now, if you see on the slide, you can see from Singapore, when we use the indirect air economizer, the energy usage will be reduced a lot, starting from general power usage, maybe is $2.75 per 10 years. Right now, if use the indirect air economizer, we can reduce over $1 per TCO 10 years. So from this one, from the equipment, we use the software to be the monitoring and controlling in terms of the usage, like enterprise, like computing, regional AS, and also centralized. We can monitor and manage every data center on the cloud computing. And then use the centralized to monitor is like a unified operation center, can be managed every data center every region that you have the data center right now. So one thing that's is not focused on that one is like we can implement by using the renewable sunset to make more energy in terms of the data center power usage. It's not just only the general energy, but we use the renewable to implement and to do the adaptive energy management on that one. So hope to be this one should be the big web that we can implement for new data center and use the digital transformation. That is from my side.
Okay, thank you, Kun Park-pong. I think next speaker will be Kun Sakdaseng. He is a regional director from Informations and Communication Solution Delta Electric Thailand, and he has long experience about the data center. And welcome, Kun Sakdaseng.
Good afternoon, everyone. So, like Mr. Wong mentioned at earlier about the data center need to transform to be the more software-defined kind of thing. So Schneider makes some presentation on that part, but Delta we also not focusing on only the software, but we also look at the hardware of the energy management, how we should manage that. So I have some slide to share with you about the conceptual design of the when customer they talk about using the renewable energy into the data center, how they can implement that part. Okay, right now when we talk about a data center and energy solution, most of our data center consume a lot of the energy to be used. Yeah, and then some country they even have the limitation of the energy supply for a data center. That's why right now some of the global data center or the global IT provider giant, they are talking about how to make a data center to be using the renewable energy, or someone may call the RE100. Okay, actually most of the company right now, they are talking about they committed to be RE100. So what is the RE100? RE stands for renewable energy, and 100 is stand for 100%. It means that this company in the screen of my presentation, you can see that they are all commit to use 100% renewable energy in their facility. So not only the IT company, but also many others company are commit to do this, because they are also aware of the energy shortage or energy problem for the like a global problem. And Delta is actually one of the company that we also commit to use renewable energy into our facility. We are one of the pioneer that we would like to emphasize on the usage of the renewable energy, yeah, to replace the fuel energy or the fossil energy of those things. That's why actually Delta in Thailand, we have two major facilities, one in Bang Pu and the other one in Well Grow. So in Bang Pu, apart from the factory, you can notice from the roof of our factory, we install a solar power, the size about 3.3 megawatt to be used in our facility. So this energy also feeding to the factory side or the equipment inside to reduce the power usage from MEA, from utility company. And also we have another facility in Well Grow as well. So you can notice that the rooftop of all the factory here, we are all using the renewable energy to supply into our facility. And in Bang Pu, actually we built data center for our own use. So you may notice this data center actually use all Delta product into this data center. But you also notice that actually we do, like I say, we really emphasize on the energy usage. So this data center, the size is about 30 racks, and we make this data center to be PUE 1.3. And we also implement the Tier 3 design compliant, as well as the ISO security information standard for this data center. So we know how to manage a data center to have very efficient energy usage. And also we implement the energy management system to monitor real time of the PUE of a data center. And then to the question that I talked earlier, that some of the IT giants at the moment, when they would like to set up the data center in Thailand, or they would like to rent the co-location or the space of a data center in Thailand, they start to ask about whether if those data centers have been already used renewable energy or not, right? So I have some data here to show you that actually in Thailand, most of the energy generation come from like 60% still come from the LPG, the gas, the natural gas. And then the other 18.3%, this one come from the coal energy. And then the energy actually from the renewable, from the wind or solar, just about 7%. And 2.4% is from the hydro generator. And then we import about 12% from overseas as energy usage, mostly like from Laos. Yeah. So if you see that the energy that flow to our system, that would be only 10% that generated by renewable energy from in Thailand. And then we import another 12% that could be the hydro from other country. So most likely the energy that flow to our data center, that would be only 22% apart from the 100%. So you can see I put the green percentage here. And then when you see here, it seems that we still have a very big gap how we can meet 100% renewable energy usage. So most of the people, they will think about, okay, if like that, I will implement the solar energy to be used in the data center, right? And then I try just to size how we should size the solar energy for this data center. I give example, if we have a data center size about 1 megawatt usage. So the IT load 1 megawatt, the input of this data center probably with a PUE of 1.6. So the total power would be 1.6 megawatt, right? But if the renewable energy from the generator plant in Thailand is only 22%, it means that if we would like to have 100% renewable energy for a data center, we must install up to 8 megawatt of the solar power in order to bring our data center to be 100% renewable energy. But you may see that also the data center only 1.6 megawatt, but we generate here of 8 megawatt, right? So it means that 6 megawatt is overusage. So if we do nothing here, during the noon time, the energy will flow back to the grid. So that's why with this kind of setup, even we can meet 100% renewable energy. However, we also have overusage of the power too much. So the solution to deal with this problem is that people may have to install a so-called energy storage system. It means that the energy storage system, it actually is kind of the bidirectional, I could say this could be the big power bank or the big battery. And in this energy storage system, it will consist of the PCS, stand for the power conditioner system, and also the energy storage, which is a battery, or in the future, this could be the supercapacitor or those things. So this energy storage is actually a programmable energy or programmable battery. So we can program it to charge or discharge the energy from the grid. So with the contribution of this energy storage system, now our system here is workable because we can program the energy storage to charge the excess energy like 6.7 megawatt here from the solar power. And then we also could discharge this energy to our data center during no sun or during nighttime. Yeah, in order to meet 100% renewable energy for our data center. All right, this is just a very conceptual how we can manage the data center to be more renewable energy usage and to meet the RE100. And right now, actually, Delta do provide the three solutions, not only data center solution, but Delta also providing the solar inverter and the solar system for our customer in Thailand. And we also providing the energy storage solution, so that with all these three data center and energy storage, we could do the integration and we could combine this kind of technology in order to make a data center more clean or more energy efficient for the future. And then if you would like to add a Delta to be a friend, you can scan the barcode here. All right, so Ajahn Monty, this is all of my presentation today.
Okay, thank you, Kun Sakda. And we heard from two big data center supplier, Schneider and Delta already. So I think they have many technology strategies, or even though they are conceptual to energy management in data center. And the last part, we come back to Mr. Calvin. I have the questions for you about, as we heard about hyperscale data center and co-location data center, which one is difficult to manage on the energy management?
Hi, thank you. That's a very good question, and you're right. Different data center needs energy management have different challenges. Broadly speaking, there are two components that we're looking at when you talk about energy management. One is the electrical system delivering the UPS power to the computer platform. The other one is the one that not many people talk about, the cooling system that then extract the heat that's being generated. Actually, the second system is a lot harder to manage efficiently. Now, the interesting thing is that in your question, the hyperscale data center has one thing going for it, which is consistency across the entire data center. In other words, in a hyperscale data center, it's normally a single-use data center, and therefore every rack will be the same. It's an 8 kilowatt rack, it's a 10 kilowatt rack. So every rack in that entire floor space has the same energy profile, and therefore we can manage in this sense. When you have consistency, the physics becomes easier to manage from the cooling point of view. So it's easier to have better efficiency when you're cooling a consistent room instead of an unbalanced room where you in a co-location data center. So in that form, I'm trying to explain that, therefore, it is a lot harder to be efficient in the long run in a co-location data center, where in a room full of racks, you may not have consistent energy profile in every rack. And one could be 2 kilowatt sitting next to an 8 kilowatt. And if you're not arranging it correctly, the cooling function is the one that creates the inefficiency. That's number one. Number two in a co-location data center, the customer usage are not consistent as compared to a hyperscale, which is very consistently drawing power from the UPS. So because of that, you could have an over provision of the UPS platform against what is being used, and that actually works against you when you do real-time calculation of PUE. Design PUE is always perfect, but real-time calculation, as you are functioning, you will be penalized. Your PUE calculation will be penalized if your consumed power is not according to your design consumption. So in a co-location data center, it's hard to manage that because you don't know what each different groups of customer may use. They can say they need 3 kilowatt, but actually they're only using 1.5 or something. That's a very different situation when you're talking about hyperscale. So in that sense, I hope that answered the question. Because of the consistency of the compute platform that's inside a hyperscale data center, in that sense, it is easier to create a more efficient environment and to manage it more efficiently on a 24-hour per day session as compared to co-location.
Okay, thank you, Mr. Kevin. And the last question to ask you, as you're expert more than 30 years in this industry, I would like to ask about the energy efficiency, about UPS and battery in uptime tier 3, for example.
That's an even more interesting question. It's been a question that has been it's been causing me to think a lot, and I've been asking this question to a lot of my engineers and my friends in the industry. If you look at the architecture of a tier 3 system, tier 3 is the tier system is designed not just about efficient. It's actually designed for fail-safe. It's designed for you to make sure that it's robust, that the system is resilient, and it does all that. But what it doesn't do is that, therefore, as an engineer, when you make something resilient and robust, what you tend to do is that you over-engineer the design so that you make sure that when it fails, something is there to take over, correct? So let me give you an example of a UPS subsystem in a tier 3 design. So normally there's a 2N system. So there's 2 UPS, there's 2 sets of battery, and at any one time, although both sets are energized, remember they're all energized, but in actual fact, the computer racks or the power is only being drawn from a single source. The other source is on standby. So technically speaking, you are operating at an efficiency level of 50%, but that's how it is because we didn't design it to be efficient. We designed it to be robust. So here's the paradox. As you are robust, you cannot be efficient, correct? But I beg to differ, not correct. Let me explain. We have an adjacent industry, which is actually our customer, which is in the computing world. The computing world suffers the same problem or philosophy problem until they develop the idea of cloudify. So today, the computer world have virtualized their server. Okay, so my question is that by the same token, if you look at the electronics and you look at all the things that's on a UPS and battery, especially today you have fast charge battery, there's a way to re-architect your UPS subsystem. Can you actually move towards what I call a virtualized UPS platform? And that's how I see the future coming, whereby in the future, a cloud customer could define a virtualized UPS to identify support for his own cloud virtual system as supported by a virtual UPS. This is all doable. I mean, not just mathematically, but the software, the capability we have, and if in the earlier presentation by the 2 vendors, they talk extensively about work done with machine learning, with artificial intelligence. Now, the same software can now be controlling the UPS and the battery to work in unison so that we can the concept of virtualizing a UPS and in order to make a 2N structure more efficient is definitely possible. And that's where I see the future coming. I believe it's around the corner. And to me, that would be the most exciting change in our industry for the data center, to be able to get into that space and therefore take us closer to our customer so that our energy system can match the usage that the cloud systems are requiring on a second by second basis. That's how I see it. So we are going to be not just linked to the computers, we're going to be connected to them so that we can provide power based on demand basis.
Okay, thank you, Kun Calvin. Right now, we will let the audience from online and ask the questions come in. And right now we have one question from the online audience coming to ask Kun Sakda about, Kun Sakda ready? They ask about what kind of the energy storage of the data center like, and they focus on the high power delivery or ensure the continuous operation response time. I mean, they try to ask how long gonna be for the energy storage in the data center. I mean,
how long is the energy storage in a data center?
Like 10 minutes, 15 minutes, what does it mean? Or I think another questions mean what type of the energy storage, like I think maybe lithium ion or lead acid, what different?
Actually, if we look at the energy storage function, it could support many functions. For example, demand response. It means that we can we can let the energy storage discharge to cut the peak or the cut power need of a data center. So that could be a very short response. But right now, the other function of the energy storage also could be used as the backup power. Yeah, it just acts like a generator or like a UPS. In that sense, the energy storage also can give the backup time of like 10 to 15 minutes as well. But the difference from the energy storage and UPS is that energy storage cannot change the mode immediately like a UPS. It takes some time. For example, if the power outage happens, and then you would like energy storage to supply the energy like a microgrid or like the backup power, it takes some time to change the mode. So during that chain, probably takes 1 or 2 minutes. So during that chain, the UPS still need to give the backup time at the moment. But the benefit of energy storage is that it could help to reduce the usage of the diesel generator. So some people start to use this kind of concept, how to reduce the energy usage of the diesel generator as well. And then if we talk about the application of to fulfill the renewable energy 100% or RE100, right? For that kind of thing, probably we need the energy storage to discharge up to 20 hours. Because what? Because the solar power give us only 4 hours a day. So if we would like to use the renewable energy to supply a data center full time 24 hours, it means the energy storage need to keep and need to discharge for 20 hours. So you can see that we could not define like just 10 minutes or 15 minutes. It also depends on your application and your function need from the energy storage system as
well. Okay, thank you for Kun Sakda. Okay, I have another question to Kun Pak Pong, because I heard and I saw a news about the Schneider. They have about the new air conditions system that I think they call front flow, right?
Yes, correct.
Yeah. What it help in energy management system over there?
Actually, from that one is like the air distribution solution that we choose make the good air distribution that different from another kind. Just from the rest floor previously, we understand that we can supply from the rest floor. By the way, from the air distribution, that one we use the like a fan wall system.
Fan wall, yes.
Yes, fan wall system, and also including use with the indirect cooling system so that one can make lowest the energy supply. By the way, from that fan wall, we use is like a flooding supply air system.
Yeah.
At that time, it can reduce the more energy from the fan inside the cooling system. By the way, from that cooling system, we have to choose also which kind of the cooling system, DX type or chill water type, and then can make more the energy from the upper the temperature of the chill water system for the hyperscale data center. Yeah.
Yes. Yes.
Okay. A question will be the same to Kun Sakda. I think Delta have this model as well, right?
Yes. Yes. Delta also have the fan wall or the front flow. Actually, I'm very impressed to Mr. Kevin to mention about the co-location, because actually the front flow cooling system also I mean, before become the front flow, it look at the pain point of the co-location that difficult to manage the airflow. So if you look at the old generation of cooling system that we blow the air down to the red floor, right? So it's very difficult to manage according to the load, especially into the co-location data center, because the downflow is the return air setting point, right? So that's why when become the front flow is actually mixed between the low cooling and room cooling. So it manages the supply air instead of return air. It means that we can program at the zone or at the location that we use less power. I mean the IT equipment use less power, and also the benefit of front flow is that it's very low pressure drop at the front at the supply air. It means that the fan consume less power comparing to the downflow technology. Yeah, that's how the front flow become more popular. In Delta, we even call this is the generation 5 cooling technology that could help the customer to save more energy in data center.
That's good answer. Mr. Karen, since we talking about the energy management, may I ask you from your experience about hot ILs or cold ILs, which one is better for energy management?
I think both of them are workable. Let me put it. That's a trick question. But Dr. Montre, on what Mrs. Kada said, let me ask you a question, and it could be an interesting project for one of your doctorate student, right? Today we are actually very discreet when we talk about the cooling efficiency. We focus on the airflow at the rack level. But if you think about it, the cooling system is not a single unit. It's not just about the airflow. It's about everything from the chiller plant all the way down to the piping system. And that is the total efficiency of your cooling, because along the way, it uses energy. So you think about it, if I need to extract 3 kilowatt of heat, which is energy, what I want to do is add up how much energy am I using across the entire supply chain of creating that cooling. We are now focusing only on the so I did some simple work recently with and we did some modeling. So if you can do a system model, a very simple mathematical model, and actually the question was that, is it more efficient to reduce the fan and the crack and increase your water flow in order to manage the output power? You understand what I'm saying? Because sometimes we make the mistake of assuming that the fan at the crack is actually more efficient than the chiller plant. It may not be. So you need to add up the total sum of energy used to extract the 3 kilowatt. And then actually you may want to moderate some of the bigger system and shut down your fan, because the fan actually consumes a lot of power. Not many people realize that. You add up all the fan in the blower, there's a lot of power being consumed to cool it. So again, this is a very interesting modeling question. And I would like to put it to you, Dr. Montre, that maybe that could be a final year project for one of
Okay. I will ask my
cooling system as an entire chain of event, not just
there could be like the system COP. If we look at the system COP
everywhere across the board, energy dissipation and how to cool it.
That could be a very long discussion, because when I build my data center in factory, the PUE 1.3, right? I need to do all the calculation, even a single component, even one LED lighting. or even the how many percentage of the fan consume the power. I have to take all the consideration in order to meet PUE 1.3. That could be a very long discussion.
When I come to Bangkok, I will have to come and see what you've done in your data center.
I know the student that you mentioned is Mr. Sakda. Okay, maybe the last question, because we have a long quite discussion, but this question will be quite tricky questions. I will ask Kun Patpong first. If I implement the DSIM software, the data center infrastructure management in the data center, it's expected to reduce my cost and help me to easy for energy management when compared to the money that I have to pay for the DSIM software.
Actually, that's one. Before we implement the DSIM software, we can calculate the ROI, right? From the DSIM software, it depends on the number of the equipment that you have to monitor. And then from the DSIM software itself, right now, we can do as an AI system to be controlled. It's like, for example, in terms of the data center, around 42% related to the cooling system. When we implement the DSIM and you want to get more energy efficiency and reduce the energy cost, it means that sometimes we can add is more AI system to control the cooling system right now. So from that one, when we control the cooling system right now by using AI, they will learning on the cooling system, on the temperature in the data center. After that, they will adjust automatically, and then you can reduce the energy cost from that one. In terms of the ROI, we can calculate on that one. But from that one might be is less than 2 years for the ROI after implement the DSIM. Yeah.
Okay, the same question to Kun Sakda as well.
Actually, I will not go to the AI yet, but from my experience, DSIM could help a lot to save energy in a data center. Why? The reason is that if we don't have DSIM, actually we don't know the temperature condition in our data center. So someone or some data center that don't have DSIM or monitoring system, they just put the aircon 18 degree or 19 degree because they worry about the front of the rack get hot air, right? But when we implement DSIM, we implement the monitoring system on every rack. So it means we open the eye, already see, oh, actually the temperature in front of the rack is too cold. And in that point, DSIM can help to monitor and to let us know to optimize the supply air, you know, like in my factory, the 1.3 PUE, right? We even adjust the supply air up to 24 degrees because we use DSIM to monitor and to keep monitoring in the actually limitation, not over 27. But before we dare to do that, we need to have the DSIM help to look at the temperature and humidity condition at the front of the rack. As well as the energy consumption, we also use DSIM to monitor source A and source B, how much power. And also the important thing is that the energy balancing between the racks. Because sometimes, you know, the user, if they don't have DSIM, it's just you are the blind. You don't know which rack use how much power already. So the DSIM can help in that sense to let them see, oh, this too much power or too high density on this rack, so they can move to the other rack to put the IT equipment. Yeah, and by that sense, DSIM can help a lot to manage the energy usage for a data center.
Okay, and the same question to Kevin, who more expertise about this one, can give any comment about the DSIM for today. You mute. Kevin, you mute.
Now you have set me up. Let me just say, okay, first and foremost, I agree with my two vendor friends. DSIM is the idea and the fact that you are able to do all the stuff that you can do is definitely good. Herein lies a challenge, and this is a challenge I'd like to say that as a data center company, operation company, the management has to get involved with DCIM implementation. Let me repeat. I implemented one, and I, as the managing director of the company, I actually had to chair every meeting for the DCIM discussion. The reason is because at the end of the day, back to, this is a computerized software. So rubbish in, rubbish out.
Yeah.
If you don't configure this thing properly, if you don't configure the DCIM properly from the vendor, it's not the vendor's fault, it's our fault. If we are not clear about our own data center design. So it's really every DCIM system is a generic system, but every implementation is very much dovetailed to that data center. And this is something that we sometimes data center management team will think that I just buy the system and I will get perfection. No, it don't work that way. You need to configure the system to your data center. You need to first understand the weakness, the strength of the design of your own data center. And now you overlay the DCIM management control over it in order for you to take away the weakness, elaborate the strength, and get the opportunity out. You understand, right? So if you don't do that, then you just misuse the DCIM application. So every data center is different. So you need to do a SWOT analysis so that when you implement a DCIM, you know how you're going to use it to do this thing of neutralizing the weakness, amplifying the strength, and take advantage of any opportunity that you see in any improvement. Okay, so that's how that's my personal experience of having implemented 2 DCIM in my life, and it's not easy. You have to be very involved as a senior management, otherwise it's not going to work.
Yeah.
Okay, thank you, Kelvin.
Yeah, thank you.
Khun Prang, you have anything else?
Okay, so I would like to thank you, so everybody. So I have one question to Dr. Muntri, as you are the founder of the Data Center University.org, and also you are an expert and also doing research about the data center so much. So I would like you to leave the last message to the audience who is interested in the data center, and also some of them are in the data center and solution industry. Yes, Dr. Muntri, you may speak something.
Yes, thank you, Khun Prang, and thank you for Informa Market for this conference webinar. And thank you for all speaker panelists. Actually, I have my own data called Data Center University.org that open for every researcher and every person who is interested, or even though the owner of the data center, if you need any information, you can go to my website. And I try to make a webinar with the Informa Market every month. That's my intentions. And the topic I expect for the next topic will be the renewable energy for data center, will be the case study of Thailand. For the date, we will update you on the website by Khun Prang or Informa Market later. And if you have any further questions, you can drop us the questions, or you can contact me or any 3 speakers that you see on the contact list, and we will try to answer all the questions that make you clear. Or even though if you have the problems, I will help, because my role is I work as an academic and public service for any company. And thank you for all the audience as well, and 3 panelists for today. And I will leave this at the end to Khun Prang again, okay?
Okay, so thank you very much, Dr. Muntri. So at the data center, we have to say that it's very important, and if you know how to manage it well, so it's really help your company a lot. So especially now, these situations, we know that the data is very important things. Okay, so I thank you to all the speakers again for the 3 speakers and the moderator to provide the solutions and to share your expertise and also the case study to us. So I would like to mention that for the Data Center University.org, and together with the King Mongkut Institute of Technology Ras Krabang, that they will be helping the conference about the AI and 5G for the evolutionizing data center at the ASEAN Sustainable Energy Week 2021, which will be organized on 14th and to 16th October in Bangkok, Thailand. So any more information regarding this event, so you can just follow us on the online channels. There is a Facebook, LinkedIn, and also YouTube. Okay, so coming to the end, the last webinar of this ASEAN Energy and Utility Digital Weeks. We want to thank you very much for staying with us. And also for the online marketplace, which is we are open 24/7 hours. It's continue to open until this Friday. So if anyone haven't have a chance to visit the platform yet, so I believe please do so, especially today. We open for the functions like the video or the call and the chat functions that you can connect with the exhibitor on our online marketplace directly. Okay, so lastly, I want to thank you once again, everybody. So I hope you stay safe and see you again next time. Thank you. ขอบคุณค่ะ